Hello and welcome, I'm your Code Monkey, and let's learn all about the awesome world of splines. This is how you can set up multiple points in your world and easily calculate a nice smooth path between them. So it's very useful for making things like roads, terrain, orbits, or really just about anything where you need a nice smooth shape and also use it to move an object along that shape. We're going to build a spline based on a Bezier curve. Now, you've probably already used Bezier curves before, even if you didn't know the actual name. If you've ever used an image or animation program where you have curves and handles to modify the shape of those curves, then you've likely already used Bezier curves. For example, I've already covered another awesome tool previously, the animation curves. That's an awesome tool and one example of a spline Bezier curve in action. That one is a spline in a virtual graph, and here we're going to build it in the actual world. Now, first of all, if you go on Wikipedia, you can see all the formulas behind it. So if you're interested in the math behind it, go ahead and check it out. But that looks quite intimidating, so here let's look at it as a more visual example. In order to understand how to make a Bezier curve, you first need to understand basic linear interpolation. So let's make a script to try it out and visually see it in action. Here I am in the editor, let's right-click, create a new C# script. Let's name this just testing, and let's make a game object, and attach the script on there. Okay, now let's open. So here let's first look at some very basic linear interpolation. And the way that we can do that is, first of all, a simple private void update, and here we go into the vector3 class, and then we have the lerp function. Lerp stands for linear interpolation. So as you can see, it takes 2 points, A and B, and then a t. The t is for the interpolation factor. So if the last argument, if t is set to 0, then we get A. If t is set to 1, we get B. And if we get a value in between 0 and 1, then we get the position in between A and B. So let's visualize this in action. Just a simple private float for the interpolate amount. And here we constantly increase it by time.delta time. And let's actually make it a modulo of 1 so that it loops back. So this one. So increase it by time.delta time and then a modulo of 1f. So as it goes up, it loops back into 0. Then we're going to use this in our parameter here, but we also need our 2 points. So for that, let's set up here serialized fields, private transform for the point A, another one for the point B, another one for the point AB. And then here we're going to do a lerp between the point A and we grab the position, then the point B, grab the position, and modified by interpolate amount. Okay, we do this and we place our point AB dot position on this one. So we should be able to visualize this object being positioned in the interpolate amount between point A and point B, and it will constantly be moving over time. Okay, so let's just set up all of these objects in the editor. Let's do the simplest thing possible, so just a simple sprite. Let's name this the point A. So this is point A, then another one for the point B. Another one for the point AB. So here just drag the references and now let's position them. So let's put the point A around here, then the point B let's put around here, and then through code this one won't be moved and it will go from here all the way in there. Let's see. And yep, there it is, exactly like that. So this is what linear interpolation looks like. We take 2 points, then an interpolation factor, and when it's 0 we got it in here, when it's 1 we have it in there, and if we pass in any other value then it gets in between. And obviously this works no matter how you put it, so if I move this one, yep, there you go. It always goes from that point onto that point. Okay, so here we have basic linear interpolation. Now let's go up one level. So let's add another point and another interpolation. So in the editor, let's add another point. This will be our point C. Then let's add another one for the point BC. And then here we're going to interpolate, do pretty much the same thing. So we're going to interpolate between point B and point C and move this one on there. Okay, that's it. Let's test. Here, just make another one for the point C, put it down there. So this is the point C, and just duplicate this one. This is the point BC. And on testing here, we just drag our references. Let's see. And yep, now we can see our logic in action. So we've got this linear interpolation from A to B, and this one from B to C. Okay, so far so good. And now here comes the fun part. Let's add another interpolate point, and this one is going to interpolate between this movement and this movement. So here, let's make another one. And for this one, let's name it the point ABBC. And now down here, we're going to do another linear interpolation for the point ABBC. Except instead of using either of the original points, we're going to use the ones composed by this linear interpolation. So we take this one and this one, and we interpolate those two. So let's see what this looks like. Here, make another one. And yep, there we have our logic. So we have one linear interpolation right here from A to B, another one from here from B to C, and then we have the yellow one, which is interpolating between these two interpolations. So here we can already see a really nice smooth curve, and obviously by modifying any of these, since this is all made by math, then everything is very versatile. So what we have here is called quadratic interpolation. And now in order to achieve our final result, we just need to go up one more level. So here let's add another point. So this will be our point D. And let's add another interpolate. This one will go from C to D. And then another one of these. And this one will be the BCCD. So let's just set these ones up. Okay, there it is. We have the point CD going from C to D and the BCCD going from BC to CD. And yep, this is what we have here. So we have one linear, one linear, one linear, then 1 and 2 quadratic. And now we just need to go one more level. So here we add our final one. So let's call it ABCD. And the logic is exactly the same that we saw in here. So we take the ABCD and we're going to interpolate between this one and this one. So here let's make another one for the ABCD. Put it in a nice purple, and let's see. And if there it is, looking at the purple, we can see it in action. So here we have a really nice smooth curve. So the object smoothly moves along the curve, which is made up of all of our points. And since this whole thing is being calculated using math, that means it's adaptable to changes in runtime. So as I take this one and I move it slightly down there, you can see the purple one, the curve of that one. And I can take this one and put it somewhere in there, and there you go, something like this. So what we have here is already one of those smooth splines that you see in those animation programs. So essentially these two are our anchors and these two are our handles. So if I place this one and I move it all the way down here and this one put it up there, and yep, look at the purple one going through this really nice, really awesome smooth curve. So by modifying the anchors, we can easily modify the shape of that curve. Look, that goes in there and then right in there. Alright, so that's all the math behind it. Now let's just clean up the code a bit to make it more understandable. So here, let's refactor this. Let's make two nice functions. Alright, so we have our two really nice functions for the quadratic linear interpolation and the cubic linear interpolation. So this one takes an ABC, this one takes the ABC and D. So here we can now clean up all this code and let's position only the final one. So let's comment all this out. And we're going to take this one and set the position, use our nice cubic lerp function, pass in the point A and so on. Alright, that's it, very simple, just using a function. So let's see what this looks like. And yep, there it is, we have our really nice, really smooth curve. So we've got all of our points, and as we move them around, yeah, we can make some really nice shapes. So there you go, just a nice little smooth curve going from here to here, and it looks really nice, really smooth. So what we have here is essentially a single segment. So we have 4 points to calculate one segment. And now in order to make some long, useful splines, all we need to do is really just add more segments. By the way, if you find the video helpful, please hit the like button and consider subscribing. It really helps out the channel. Now over here I have a proper spline class that I prepared previously. It simply builds upon what we just saw. Specifically, it has a list of all of the anchors. And each anchor is just a simple object that contains a position and the handle for the left and right side. Then it also has a simple editor script. So with this I can position each handle and each anchor wherever I want. So very easy to use. And then I've got a spline follower script, which takes a reference to the spline and simply grabs the position from it. So here it is in action, the object following along with the spline. And on the spline, I also have the option to make it a closed loop. So if I do, yep, it connects the last anchor to the very first one, and here we have something really nice, really closed. Also, in this more advanced version, I also have some rotation. The way that's handled is the spline also has a list of points. So these are dynamically generated at runtime. Each point simply contains its position, a forward, and a normal vector. So using that, I can make my nice spline and then enable a car object. And yep, there you go, the car correctly interpolates along the spline, and it also has the correct rotation. And the last thing that I have is a script to make a spline mesh. So once again, it takes the underlying spline, and then what it does is simply dynamically creates the mesh by going through every single point on the spline. So for every point, it adds 2 vertices and connects them to the previous 2. So that way it creates a mesh alongside of the length and the shape of the spline. So if you combine that with a very simple road sprite, and yep, here is the outcome. So we can see over here, instead of shaded, put it on wireframe, and we can see how this whole mesh is constructed. So for every single point, it adds another 2 vertices and connects them to the previous one and goes all the way over. So just take this, then enable the car on top, and here we have a really nice scene. So we've got a road mesh, and we've got the car driving along the road, and yep, it goes along perfectly. And of course, this whole thing is being driven by math, so I can just modify any of these points, and it all connects perfectly. So I can modify the shape, and whatever I give it, it perfectly follows along the path, and yep, just like that. Alright, so here you can see how splines are an awesome tool you have at your disposal whenever you need to set up some really nice smooth curves. As always, you can download the project files and utilities from unitycodemonkey.com. This video is made possible thanks to these awesome supporters. Go to patreon.com/unitycodemonkey to get some perks and help keep the videos free for everyone. If you found this video helpful, consider liking and subscribing. Post any questions I have in comments, and I'll see you next time.